For a confidence level of 95% with a sample size of 16, we're asked to find the critical t-value. I'm told that rounding to 3 decimal places is acceptable. So, remember, we are looking at a t-curve, which looks very much like a normal curve. Becomes more and more normal as your degrees of freedom increase. Okay, and we are asked to find t-values, critical t-value, right here. And this will be its opposite over here, that puts 95% of the data, 95% of the data between those 2 points. That leaves us with 2.5% in the tails. Okay? So what we're looking for is that t-value right there that has 97.5% of the t-curve's area, the data, to its left and only 2.5% to its right. That's what we call a critical t-value that we use to create a confidence interval. And for this, we use the inverse t function on the calculator. So we go to the calculator and we do second and then this bars key to get, if you can see this distra up there, okay? And it's the inverse t function, which is number 4. So you can just hit 4 and it'll come up, except I was not in the right place. So let's quit the lists and do that again. So we're going to do number 4 and it comes up just as inverse t. Now the inputs that you need for inverse t are the percent of the curve that is to the left of the point you're looking for, and we need to enter it as a decimal. So remember, it was 97.5%, so that's 0.975. The other piece of information that the calculator needs is the degrees of freedom on the t-curve that we're looking at. Remember, the degrees of freedom are n minus 1. Our sample size n is 16 in this case, so our degrees of freedom are 15. So we'll put those in, and it'll take it a second to calculate it, and it comes up with 2.131 if we round it to 3 decimal places. So that's our answer. This critical t-value right here, the critical value for a confidence level of 95% with a sample size of 16, is 2.131.